Hi, I'm Lakshmi of 3rd BSc Physics. Today I'm going to take a seminar about design and operation of serial input parallel output register SIPO with diagram and explanation. First, we are going to see about registers. Registers are the temporary storage location inside the CPU that holds data and addresses. The register file is the component that contains all the general purpose register of the microprocessor. A few CPU also place a special registers such as PC and the status register in the register file. Types of registers. There are various types of registers that are used for various purposes. The most usually registers that are accumulator, data register, address register, program register, memory data register, index register, memory buffer register, shift register. They are used for various operations. First, now we are going to see about shift register. A shift register is a digital memory circuit found in calculators, computers and data processing systems. Registers, that means shift registers, are commonly used in converters that translate parallel data to serial data. Next, we are going to see about types of registers. There are types of shift registers. There are 4 types of shift registers, namely SISO, serial input, serial output; SIPO, serial input, parallel output; PIPO, parallel input, parallel output; PISO, parallel input, serial output. Now we are going to see about serial input with parallel output. The shift register, which allows serial input and produce parallel output, is known as serial input parallel output registers. The block diagram of 3-bit SIPO shift register is shown in the following figure. The circuit contains of 3 D flip-flops. That means output of one D flip-flop is connected to the input of our next D flip-flop. All these flip-flops are synchronous with each other since the same clock signal is applied to each other. Next, the operation of SIPO. In this shift register, we can send the bytes serially from the input of leftmost D flip-flops. Hence, this input also called as serial input. For every positive edge triggering of a clock signal, the data shifts from one stage to next stage. In this case, we can access the output of each D flip-flop in parallel. So we get parallel outputs from this shift register. For example, let us see the working of 3-bit SIPO shift register by sending the binary information of 011 from LSB to MSB serially at the input. LSB means least significant bit. MSB means most significant bit. In D flip-flops, LSB B1, MSB B0, especially for D flip-flops. The table shows. Assume the initial status of the D flip-flops from the leftmost to the rightmost is here Q2, Q1, Q0 equal to 0, 0, Q2, Q1, Q0 equal to 0, 0. Here Q2, Q0 and Q0 are MSB and LSB respectively. We can understand the working of 3-bit SIPO shift register from the following table. The initial status of the D flip-flops in the absence of clock signal is Q2, Q1, Q0 equal to 0, 0, 0, Q2, Q1, Q0 equal to 0, 0, 0. The binary information 0, 1, 1 is obtained in the parallel at the output of D flip-flops of the third positive edge clock. So, the D flip-flops SIPO shift register requires 3 clock pulses in order to proceed the valid output. Similarly, the n-bit SIPO shift register requires n clock pulses in order to shift n-bit informations. N-bit means n equal to 0, 1 or 1, 2, etc. That is infinity. Hence, I conclude with the indication of shift register with serial input and parallel output. Thank you.